Hello everyone, today we are going to discuss this new problem: convert sorted array to a binary search tree. Okay, so a binary search tree is always like if you do a search in order traverser, then in order traverser would always give you a sorted list. Okay, so here it is also mentioning that this height of this tree should also be balanced. So which is a property of an AVL tree. So AVL tree has the left height of the left subtree and the right subtree, the difference between them cannot be more than 1. Okay, so this is the idea. So this tree is always already sorted and sorted in strictly increasing order. Okay, this is already given to us. So how do you approach it? So one thing is, because this is already a sorted array and you want to convert it into a binary search tree, then the intuition here is we should go to the middle element and keep the middle element in the node of the tree, and then go to the left hand side and find its middlemost element, and then go to the right hand side, find its middlemost element, and then put it in the respective root nodes, and similarly we can go about it. Okay, so any point in time we should have a reference to the left and the right element of the array that we are looking at. So for that, probably we would need to create a helper method, and let's try to create that. So what would be that? Public tree node, and what it would get is build bst, okay, binary search tree, which is balanced one. It would take the nums, and it would also take left element and right, the left pointer and the right pointer. Okay, so how should you go about it? How should this be called? First of all, right, if nums is null, then this is straight. If nums directly return null. Okay, otherwise we would return, and we would pass here nums, and nums dot left, which is 0, and right would be nums dot length minus 1. Okay, so okay, let's create the base conditions here. So we would always be referring to, so we would create the left structure and right structure, and we would put this okay, so let's say if we reach the tunnel state, then in that case would be if left is greater than right, in that case return null. Okay, what should we do in other cases? In other cases, what could be the other case here? If okay, so we need to create this element. If this, okay, we would calculate midpoint, right? Mid equal to left plus left, right minus left. So we are doing this to avoid any overflow. This would avoid any overflow. Okay, okay, so this middlemost element we have this middlemost element, and we would put that into, you know, nums mid. We would find this element. Okay, and with this element, what should we do? We would just create a tree node, because this is what this is expecting, and maybe we can call it root or node, whatever you want to call it, and we will create new tree node, and we'll pass this as element. So this would be so now after this we would need to, you know, get the left and the right one. So we would recursively call this to get the left element. Okay, and call it with nums, and we'll pass on 0 and mid -1. Okay, this is our left child, so our root dot left would be this one, and root dot right would be same. We would copy this, and it would be from mid +1 to right. Okay, so that way we would recursively be calling this, and finally we would return the root. Let's try to run it. We again check if everything is fine. Okay, let's try to run it. There is a semicolon expected here. Wrong answer. Okay, got it. I think yeah, this should not be 0, because we are getting left. We should start from left. Yeah. Okay, our solution is accepted. Now let's try to submit it and see. Okay, we got it executed in 1 millisecond, which is faster than 43.96 of the solutions. Let's try to submit it again, and this is fairly, yeah. Okay, okay guys, see you in the next one.